All right, for this week's advanced interactive concept question, we looked at elephant toothpaste. And so I've seen videos of what this actually is, but I didn't know it was called elephant toothpaste. But after realizing, I should have realized that it obviously was going to be called elephant toothpaste. I was very excited to do this because I'd seen it a lot of times. I've never personally done it before this experiment, but I was really interested to see how it would turn out, and I was not disappointed when I did it. It was fun to watch. So elephant toothpaste is created by the chemical reaction happening inside of the bottle. Obviously, it's a chemical reaction, and then it happens. So the things that you need, you don't need a lot for this experiment, but as stated in the question, you do need dish soap, yeast, hydrogen peroxide, and warm water, and food coloring. You don't really need the food coloring, but it is an additive, so the food coloring doesn't really determine if the reaction happens or not. It's just kind of in there for show. I wish that in my experiment I would have added more food coloring just for it to be prettier, but I just added blue, so that was fine with me. So the dish soap is needed in the experiment because it'll help create the foam. The hydrogen peroxide is hydrogen peroxide naturally goes through a decomposition reaction. It goes from hydrogen peroxide, which is the reactant, and it decomposes into water and O2 gas. So that's the natural reaction here. And that happens on a daily basis. I've noticed in my high school chemistry class that all of the hydrogen peroxide bottles were dark, and they were able to be pushed down, compressed or decompressed. And after my chemistry professor told me why they were in these bottles, it was because this decomposition reaction is natural and it happens all the time, and the reaction doesn't happen as easy if it's in darker bottles, but the bottle being able to be compressed or decompressed is easy to allow the oxygen gas to build up in the bottle. You don't want the bottle to explode because of maximum pressure being reached. So the warm water is used for the yeast to activate the yeast. And so yeast has an enzyme called catalase. And as you can probably guess, catalase comes from the word catalyst. And yeast being a catalyst means that it speeds up certain reactions. So yeast in this case is used as a catalyst. And to activate the yeast, you need the warm water. So you mix the yeast inside of the warm water, then it's activated. In baking, you have to activate yeast this way too, so you can't just throw it in there, which is kind of a bummer. And then the food coloring is to make it pretty, or not so pretty. You don't really need it, but it's a definitely plus, as I said earlier. So as I keep saying, the decomposition reaction is from hydrogen peroxide to water and oxygen. And when you add the yeast inside, it allows this reaction to happen really, really fast. So the hydrogen peroxide decomposes into water and oxygen gas really, really fast. So you have water at the bottom, and then the oxygen gas comes up. So the oxygen gas isn't actually a gas. In this case, it turns into the foam because the dish soap collects the oxygen gas, and that's what makes the foam happen. So that's fun. I didn't know before doing this experiment that you needed dish soap for it, and I thought that was interesting that the dish soap caught the oxygen gas to make this all happen, which was really fun. So this is my experiment. It worked, obviously. It was fun. I had some friends be there and do it with me, which was really nice. It's blue. I wish I would have put more colors in it just to see like the other colors, because sometimes you'll notice on like YouTube videos or pictures that they're all in different colors. So I wish I would have done it in different colors. One thing that is good about this experiment is that it's just water and dish soap basically, or and oxygen inside dish soap. So it's really easy to clean up. So you just clean it up and you can decompose it the same way, which was really nice. It was fast cleanup. Yeah, so that was my experiment and my what happened when I did it. Thank you.